All right, welcome to The Explainer. Today, we're going to talk about something we've all done, probably dozens of times, taking a test. But what if I told you that the simple score you get at the end, getting 8 out of 10 right, is actually missing most of the story? Let's kick things off with a little question that honestly blows up how we usually think about test scores.
So just think about this for a sec. You and your friend, you take the same test, and you both get exactly 5 questions right. The obvious answer is, yeah, you performed equally well, right? Well, maybe not. And figuring out why is going to completely change how you look at testing.
See, it all boils down to 2 totally different ways of thinking about a score. The traditional way is kind of a blunt instrument. It just wants to know how many did you get right, and that's it. But there's this much smarter model called item response theory, or IRT for short. And it's more like a precision tool. It doesn't just ask how many, it asks which specific ones you got right. And trust me, that changes everything. To really get our heads around this, we have to start with the big fundamental problem in how most tests have been scored for, well, forever.
Okay, here's the heart of the issue. Simple scoring treats every single question like it's the same. To see why that's just wrong, imagine a high jump competition. Is clearing a bar that's 4 feet high the same accomplishment as clearing one that's 7 feet high? No way, of course not. But that's exactly what traditional scoring does. It gives you 1 point for each, completely ignoring how difficult they were.
So, how do we fix this? Well, this is where IRT gets really brilliant. Instead of seeing questions as these identical little blocks, it basically decodes the unique DNA of every single question. It's like getting a full diagnostic report for each item on the test. The simplest IRT model is what we call the one-parameter model. It's focused on just one single thing, a question's difficulty, which we call B. This is pretty much just the height of the bar in our high jump analogy. A question with a high B value is a tough one, just like a high bar is tough to clear. Simple enough. But just knowing the difficulty isn't quite enough. So the 2-parameter model adds a second really crucial trait, discrimination, or A. This tells us how good a question is at telling the difference between people who are really close in ability. A sharp question, one with high discrimination, can separate someone who sort of gets it from someone who really gets it. And then for multiple choice tests, there's one last layer we can add, the 3-parameter model. This brings in the C parameter, which handles guessing. I mean, what's the chance someone with no idea could just get lucky and pick the right answer? That's what C is all about. You can think of it like that high jumper who just stumbles, trips, and somehow accidentally flops over the bar. It happens, right? So the model has to account for it. So we've got difficulty, discrimination, and guessing. With these 3 things, we can finally get to the real aha moment of IRT, which is figuring out how much actual measurement value each and every question gives us. Now, you might be thinking, okay, this is a lot of math. Why are we doing this? What's the point of all this complexity? Why not just count the right answers and call it a day? Well, because all this work lets us measure something incredibly valuable called information. The big payoff for all that complexity is a concept called the item information function, or IIF. The best way to think about it is as a curve that shows you exactly how much precision, how much information a single question gives you about someone's ability. And what this tells us is that a good question isn't just a hard one. It's a question that provides a ton of information, which is tied directly to how sharp it is, its discrimination. Just look at this comparison right here. A question with low discrimination, its information curve is short and wide. It tells you a tiny bit about a whole lot of people, but it's not very precise. But a high discrimination question, its curve is tall and narrow. It gives you super precise information, but only for a very specific group of people whose ability level is right around that question's difficulty. So by focusing on the information we get from each question, not just whether it was right or wrong, we can come up with a score that's just fundamentally more precise and honestly more meaningful. And here's where your jaw might drop. On a simple 20-question test, the old-school way of scoring can only give you 21 possible results. 0 correct, 1 correct, all the way up to 20. But with IRT, because it's looking at the pattern of right and wrong answers, there are over 1 million unique possibilities. That's the difference between a ruler with 21 little marks and one with over 1 million. It's a whole other level of detail. So this table, this right here, finally answers our original question. Look at this. We've got 5 different people who all got a raw score of 3. They all got 3 questions right, but look at their IRT ability scores, what the model calls theta. They are completely different. They go from nearly average, at negative 0.05, all the way down to a super low score below -3. Why? How is that possible? Because it really, really matters which 3 questions they got right. It all comes down to the pattern of answers. So examinee A has a really logical pattern. They got the easy questions right and the hard ones wrong. The model looks at that and basically says, yep, that makes perfect sense, and gives them the highest ability score of the bunch. But then you have examinee C. Their pattern is weird. They missed the easy stuff, but somehow nailed the hard questions. The model sees that as a very unlikely, inconsistent pattern, which leads to a very, very low ability estimate. Now, this incredible level of precision isn't just some cool academic trick. It's actually the engine that powers the entire next generation of testing, making assessments way smarter, faster, and fairer for everyone involved. Let me introduce you to computerized adaptive testing, or CAT. This is literally a test that customizes itself to you while you're taking it. It uses all that IRT logic to pick the perfect next question based on your answers so far. One that's not too easy, not too hard, but gives the most possible information about where you're at. And that means you get a more accurate score with way fewer questions. No more getting frustrated with questions that are way too easy or impossibly hard. So here's how it actually works. You start with a question of about average difficulty. If you get it right, the test gives you a slightly harder one. Get it wrong, it gives you an easier one. With every single click, the computer is zeroing in on your true ability level, making its estimate more and more precise until it's confident it has an accurate score. It's like a dynamic conversation between you and the test. So, we'll just leave you with this final thought. We've gone from just counting right versus wrong to a system that can build this incredibly detailed, precise profile of a person's ability. If our tools for measurement can become this personal, this adaptive, what does that unlock for the future of learning, for career paths, for helping every single one of us realize what we're truly capable of? That's item response theory explained.